โอเคค่ะตอนนี้นะคะเราก็อยู่กับนักวิทยาศาสตร์ NASA ทั้งสองท่านนะคะที่เขานำเซ็นเซอร์เนี่ยขึ้นมาบนเครื่อง DC-8 ด้วยเดี๋ยวเราจะมาดูผลกันว่าที่เขาขึ้นไปเนี่ยเขาเจออะไรกันบ้างโอเค so here's the guy so can you introduce yourself please
My name is Josh DiGangi. I'm a physical scientist researcher at NASA's Langley Research Center.
I'm Jason Miech. I'm a postdoc researcher at NASA Langley with the Trace Gases Group.
Okay. So you guys already fly like two flights with DC-8 already. So how was it? How was everything? Like, what is the data? Like, what did you guys found? Is there any interesting stuff that you can show me? Yeah.
Sure. So the flight track that we flew for both days was pretty much identical. Kind of the major finding was that the two different days that we sampled are very similar with a lot of smoke enhancements up north and kind of getting cleaner from that smoke south in the Bangkok area.
Okay. Cleaner smoke from the southern part of the area.
Meaning that smoke hasn't traveled all the way to Bangkok. It's
Okay,
kind of
so
right now
Less smoke.
Less smoke.
Okay, so it's like more smoke in the up north. Yeah.
Yes.
So it means the northern is worse in air quality.
In terms of air quality, yes.
Okay. So what did you guys found? Like, can you explain like this graph, please?
Yeah, so this is showing the flight track, and we're measuring the ratio of methane to carbon monoxide, both greenhouse gases that come from a variety of different sources. And so by looking at the ratios, we can determine, or try to determine, what sources the air mass originated from, or maybe it's a combination of different sources, so indicative of mixing. And so here we start to see kind of a gradient between the south, kind of near Bangkok, these actually higher ratios.
Higher ratio, okay.
And then moving north, we get lower ratios.
Okay.
So the lower ratios could be indicative of biomass burning, so the smoke. And then perhaps a more urban influence south.
Ah, I see. So higher ratio. I'm sorry.
So I was just saying, so a simple way to look at it might be, if you have a fire, fires do not burn very efficiently. They usually, unlike a car or a factory which needs high efficiency, fires burn at whatever they burn at. That's why you get a lot of smoke. That makes a lot of carbon monoxide, and we can use that high level of carbon monoxide as an indicator of fire. Whereas, say, like a car or a factory, it will tend to have less carbon monoxide and a little more methane. And so if we see maybe about the same amount of carbon monoxide and methane, we can say, oh, that's actually from some sort of urban or some sort of combustion from a machine. And then there are also types of air where we see a lot of methane, but not very much carbon monoxide. And that can be an indicator of agricultural emissions. So farming, things like that, tend to make a lot of methane from fertilizers, but since there's no combustion, there's not very much carbon monoxide. So we can use the ratio to determine which of those categories it's in.
Oh, that's so interesting. That's really interesting. Okay, so like the bigger ratio and the smaller ratio will be like different causes.
Correct.
Yeah, okay.
And then sometimes you have fire emissions, so you see a little more, but then you have agricultural emissions on top of that. So we can get very complicated, and that's just with two gases. If we add more gases, we can tell more separation. We can start to look at the differences between urban sources even, and things like that. Higher and lower efficiency fires, whether they're just sort of smoldering on the ground or if they're big and flaming. Yeah.
Okay. Can you differentiate between forest fire and agriculture fire?
Yeah, usually you can. So you tend to get a lot more carbon monoxide with agricultural fires than forest fires tend to be much larger and burning. Though forest fires go through a life cycle, they tend to be very strong at the beginning and then they sort of die out. And so you can look at indicators like that. But we have other measurements on the plane that give us more information, like gases like HCN, acetonitrile, and we can look at how these vary and figure out, okay, does this look more like an agricultural fire based on the mixes of these gases versus the forest fires?
Oh, that's interesting. Okay, so what about this graph? What does this mean? This is methane and this is carbon, right?
Yeah, so this again, I'm just plotting the ratios. So this was that methane to carbon monoxide. The same data that I showed in that other plot,
okay.
just plotted against each other. So you can start to see, like here is that high methane spike. So that could be associated with some sort of agricultural area.
Okay. So mostly it's like north here, right?
So north, I just arbitrarily picked north of latitude 17 to try to capture that northern area of Thailand that is seeing some smoke, kind of the south, kind of near Bangkok, just to see if there are any differences in these ratios that I could tell. So just another method of looking at the data, trying to understand what's going on.
Okay. And this one is also, this one is have like carbon dioxide. It's
Yes.
a new one.
Yes, so this is another one of those ratios that we use to look at the different regimes. So here it's carbon monoxide to carbon dioxide. And you can see we have different lobes going on, different slopes indicating different combustion regimes going on. So here we have a lot of CO2 and low CO, so that could be indicative of higher efficiency combustion. Where you have this high CO and low CO2 could be more of that biomass burning.
High CO, low CO2, biomass burning, something like that.
Less high CO2,
Less
I would say,
high
yes.
Sorry.
You still are seeing an increase in CO2, just you have a lot more CO compared to the CO2 relatively.
It's like ratio is bigger.
It's bigger, correct?
Yeah, ratio is bigger. It's mean like agriculture burning mostly because it's biomass.
Right.
Mostly it's burning biomass.
Actually, some of the biggest values I've seen are from things like peat smoldering in Borneo. That was really interesting. That was another
Okay.
campaign that I did.
Okay, I see. So you did a lot of stuff. So this guy, this one also the same thing.
So this is the second flight. So this is the flight we did yesterday, and this was the one we did
The first
3
day.
days ago.
Can I see the one in like okay.
So you can see they're actually pretty similar.
Yes.
That's expected. The weather didn't really change between, the couple days between the flights. But hopefully going further into our campaign at Thailand, we'll start to see different weather patterns. And hopefully we'll be able to fly the same flight path, but see different things.
Okay, I see.